There we go. So a few things I'm going to teach you today is really about communicating your answer. Not exactly what to write, but how to write it down so it's neat, clean, understandable by anybody. Another way, if you don't like the judge-jury metaphor of you're presenting your words to a judge and jury, they need to see step by step. Think about if there's somebody next to you that comes in, starts tomorrow, and don't speak language at all. Either they can't speak or they don't speak your language. And all you can do is show them your paper. And they can't hear or understand any words. Could they follow your work and understand it? If you did it step by step, one thing at a time. That's how you want to show all your work. Now, I need to see algebra and not arithmetic. And I'll show you the difference in a little bit. Let's get started just on the first ones here. And the little thing that I'm going to start off with, which I'll ask you about these later, is just that as you're solving or simplifying expressions, you're going to have a line of equal signs going vertically downward. Each line is equal or the same as the one before. It's just written differently. So you guys know like what? PEMDAS or order of operations. Where you start, what to do next, what to do after. So the first step is going to be parentheses. Now, if you actually underline the 3 minus 2, somebody that couldn't understand that, or a jury that didn't know any algebra, they would know, oh, they underlined that. That's what I should be looking at. It makes sense. Okay? And it would be helpful. So, and we're going to do only that, just that one step per line. There's 2 parentheses, so I'm going to put 2 parentheses. Close it, just change the 3 minus 2 to a 1. Keep everything else the same. Squared minus 5. Close parentheses. So you don't change anything except that one detail. That way nobody gets confused on what you did. It's very obvious. And if we try to line these numbers up, like -6, keep those lined up, and -5, keep those lined up, it'll make it even easier. So next is the exponents. So we have 1 to the 2nd power. Do you really need to write a separate step for you to know how to do this? No. Not for you, but for maybe somebody else to understand. Maybe they just need to see that. So you see how these are vertically aligned, -6, -6, the equal signs, the -5s are kind of right by each other. Very easy to follow what just happened. And the same thing with the next step. 1 minus 5. Okay. Lastly, we have -6 times -4, which is positive 20. Now, I use a positive sign here only when I multiply 2 negatives, because it's a little confusing. You don't really have to do that if you don't want to. It's fine if you leave it as just 24. But sometimes when you're doing these and you're really good at math, you're really good at algebra, the things that get in your way, it's negatives. So I just make it a point by always putting a positive sign when there's 2 negatives that make it positive, so it's very clear what just happened. All right. So if you need to write this down, what we did first, we did parentheses first. And taking notes will be different for different people. Taking notes should be for you only. It should not match everybody else's. Taking notes is not copying the board, see what's up there. But anything you did not know or you might need to know later, you write down so you, in case you forget, it's there. If you've known it for years, obviously you don't need to write it down, and you'll probably be fine. Okay. So it could be different. So if you're really good at order of operations, maybe you don't need to write this down. If you're looking at this like, I might have gotten that wrong, then no, maybe it's a good idea to write it down. You can see how I color-coded it. The 2 parentheses are green. The exponent is yellow, and multiplying is magenta. Little details here. Let's see here. Is it always multiply, divide? No. These can be in different order. It's always multiply, divide, or divide, then multiply from left to right. For instance, 6 divided by 2 times 5. You'd actually do division first. 6 divided by 2 is 3. 3 times 5 is 15. So it's not always multiply everything and then divide everything. It's in order from left to right. Same thing here. This could be subtract, then add from left to right. And later on, when we get to them, exponents also include square roots. You'll learn later this year, square roots are actually exponents, but they're fraction exponents. Square root is the same thing as to the 1/2 power, fraction exponent. So we have to do it radicals or exponents and square roots. It's almost at the same place right here. That's pretty good. Feel free, if you have clear pencils, you want to try to use colors and things like that to help you out, or highlighters. Highlighters are a little more iffy because you can't erase them, so use carefully as your discretion. So, a few things that are new here. It's not really about the math and what to write down, it's how you write it. Try to line up everything vertically, right? Equal signs all the way down. Anything you didn't change, trying to line up. All these -6s you can see are all lined up. These -5s are pretty much lined up. You want to do that as much as you can. Keep things very clear of what just happened step by step. Oh, and box your answer at the end. Always box your answer. You can circle it too, but definitely have some sort of signal to the jury what it is you're saying the answer is. We'll start looking at number 2. We gotta. This means what? When you have a divide. We already know that. We don't really use this divide sign that much in algebra. So 6 divided by 2 is pretty much always written as 6 divided by 2. If you look really close and you zoom in on the division sign, you can see that this is actually right here. That's the same as this. These 2 dots represent the numbers that go on the top and bottom. The division sign is actually a fraction. Fraction is divisions, divisions are fractions. Now, why do we use fractions instead of division sign for everything? Could be easier sometimes, but when you get to stuff like this, like 1/3, and you have to convert that to a decimal, it's approximately not equal to, it's like 0.333 or 3 repeating, and you can't really have that, so we have to use fractions. It's a lot easier. For like 1/3, 1/6, 1/9, they all have those repeating parts. We use them there. So again, let's just practice here. Equal signs. Anything we're not going to change, you kind of line up vertically as much as you can. It's good to have a little game plan before you start. And here's the beauty of taking notes. I outline the homework kind of in pairs. Or maybe, quadruples here in this case, order of operations. If you write the notes kind of right in the middle, you have it right there to refer to in case you need it. So if you're not sure what to do first, and this is already written down, well, you have parentheses, then you know to start right here. And then next we're going to do exponents, so that's going to be the 3rd power. Then we're going to multiply, so then we're going to divide by 9. And lastly, you're going to add -6. So you already know what you're going to do before you even start the whole problem. You may not be able to see every single step before you start, but it's good to at least have the first 2 or 3 steps. So one thing at a time. We got 8 minus 5, which is 3. 3rd power divided by 9. So when I check homework tomorrow, I'm looking about really how you write your work down and how much you write down. Not that it's, and the answer is important, of course, but getting everything in there as much as possible. What is 3 to the 3rd power? 27. 27. Very good. Often this gets mistaken for 9 because it means 3 times 3, but this means right here 3 times itself 3 times. So 3 times 3, 9 times 3, which is 27. Now, this is an example of what you do not need to show me. This is arithmetic, not algebra. I don't really need to see that. I just write that for illustrative point of view. But if you can just say 3 times 3 times 3 is 27, that's perfectly fine. And then again, one thing at a time. Not because you need to have it written this way, but because that's what's going to be easiest to understand if you didn't know any algebra. you would actually want to know, okay, divided by 9, and then 6, negative 6 plus 3, or 3 minus negative 6, or 3 minus 6, okay? We'll get 3. In general, I like you to write it vertically, but you can see right here I ran out of space. So I just off to the side. All right. So I did a couple. Why don't you guys do a couple? And you can do this one of two ways. You can try it on your own, then check with somebody. If you're not sure about these, work with somebody step by step as you go along, making sure they're the same. If you have any questions, check with someone next to you, in front of you, behind you, or raise your hand. So you guys. So I got to this point, and I just want to point out that when fractions involve, some seem to be more concerned about them than others. Just keep in mind that if you know how to take half of something, the rules apply for any number. So what's half of 10? But that's the same thing as 10 divided by 2, right? So half of 10 and 10 divided by 2 are both 5. So it's the same thing whether it's a 2 on the bottom or a 3 on the bottom. So that means a third of 30 is the same as 30 divided by 3. So you can always what they call extrapolate, or think inductively, like if it works for this number, it must work for that number. So there's a pattern. So we get negative 10. Negative 30 divided by 3. Negative 10. Now on number 4, there are unwritten parentheses on the top and bottom. Right? Unwritten parentheses on the top and bottom. So you always simplify the top and bottom first. It's 6, and then it'd be negative 18 minus 2, equal sign, which is 6 over negative 20, which most of you already know this. It goes without saying, always reduce your answer. So we can divide top and bottom by. All right. Now, something new you might learn right now. We usually don't write the negative on the bottom of an answer. We'll usually write either negative 3/10 or negative 3 over 10. So either in the front or on top. So you want one of those two, not both, but one or the other. The preference is usually this one with a negative on top. You just have to be careful because this is a negative 3. And right here, this is a negative 3 also. It's just the negative's way in the front, but it's still negative 3. So it's just easier when it's right there in front of it to remember that it's negative 3, and you won't get confused. So yeah, but never really put the negative on the bottom of an answer. You can leave it there as you're working, but for reasons you'll find out as you go along, that creates problems with the negatives on the bottom. All right, good. And no decimals, don't convert to decimals, don't make it a mixed number. You want your answer as a ratio. Ratio just means a number on the top and bottom. So think of the division sign we just did. You want a number on the top and a number on the bottom, and that's good enough for an answer as long as it's reduced. No mixed numbers, no decimals, nothing like that. Now you can use a calculator for any homework, quiz, test, final. And there are calculators that do fractions. So if this is something you're not quite sure about and you don't want to mess with and make your life easier if you don't have to worry about if you're doing fractions right, you can invest $8 to $10, get a calculator that does fractions, and that'll take you all the way through algebra 2. So by the time you get to geometry, you have to have one anyway. So you'll just be getting one earlier, and it will help you. So you'll never have to miss any algebra problem because of arithmetic from elementary school. More reason. All right. Now, the whole purpose for doing all this is really coming around the corner now. Can you take some numbers, plug them in, and simplify? Okay. Use parentheses. I'll do 7, and maybe 9. Use parentheses when you plug something in. Equals. Anytime you plug something in, make sure it's in parentheses. It'll help you decide, is that a -5 or times -5? Not the parentheses, sometimes a little confusing. So always use them just in case. And if you're not sure about the negative numbers, remember when you end subtracting, think money. If you owe $5 and then you owe $6 more, -5 and -6, that means you owe 11. So do three negatives make a positive here? No. So do two negatives always make a positive? No. Only when you're multiplying or dividing do two negatives make a positive. As in the next step, -5 times -11 is positive. So that's one of those little things that's confusing. Two negatives do not always make a positive. Adding, subtracting, or counting money, yeah, it stays negative because you owe more money. Now, as we're going along, I'm going to do number 9. If you have the hang of this, you need to self-direct yourself. I'm about to do number 9, you think you know how to do it? And just do number 9 looking down by yourself. If you're still kind of confused and not quite sure, keep looking up and follow along, or at least check back and forth. But at some point, you want to switch over from I'm kind of watching how to do it to I'm doing it myself. And you might have been able to look at this from the very beginning and just look down the whole time and get it right. So you kind of self-guide yourself. You kind of know if you kind of get that feeling in your gut that I might get this right or I might get this wrong. Change your how you're doing these accordingly as you need to. 2 to the third, 3 plus 6 minus 5 squared parentheses. Parentheses, then exponents we can do next. 2 to the third power is 2 times 2 times 2? 8. Good. And then we got 1 to the second power, which is 1. Parentheses again. 8 times 4, which is 32. So if you told yourself, I know how to do this, and then you maybe made a mistake and didn't show as much work, now you kind of know, like, oh, maybe I'm not quite there yet, I need to slow down. If it's just arithmetic, then you know what, that just happens. You'll learn as you make mistakes, and that's all there is to that. You can't always make everything right. Always the first round, that's not easy. Very good. So now we know how to plug things in. Let's actually use this for something realistic. Flip it over. Reading to purpose is really saying that you already did the problem and you got this answer and checking to see if it's actually right. Okay? And as it says up in the purpose and directions, you're going to write whether it's the right answer or solution or not a solution. So by the end of this, you're going to have 2 possibilities. Either the left and the right sides are equal. That means it's a solution, number you plug in, and that you're done. Now, if the left side is not equal the right side, that means it's not a solution. And you need to redo the problem and find a mistake. Now, redo does not mean erase and start all over. It means find a mistake. Usually it's a negative. You don't start all over and say, like, especially when you need help, you don't want to erase it and say, I didn't get number 5, and you just erased all your work. Chances are you had it all right except for one thing, and that's why I didn't know it. So leave your work there and find the mistake first. Okay, so let's give this a try. Plugging it in. So the question is negative 19 over 4, does that actually equal negative 7 over 4? Notice how I moved the negative to the top, just to keep it obvious that this is negative 7. That's okay. Plus negative 3. Now, if you have a calculator of those fractions, you can just type that in and see if it comes out to negative 19 over 4. If not, you might have to do it the old-fashioned way. Some of you learned denominators. Some of you learned reverse division. The reverse division seems less common, but it seems easier for most. What I mean, like when you learn subtraction, and you learn it is actually addition and reverse. 4 plus 5 is 9, which is 9 minus 4 is 5. You just reversed it. The same idea here. You know that these need to be the same denominator. This needs divided by 4. So to find the top number, it's just what divided by 4 equals negative 3. So what divided by 4 is 3? 12. Yeah. And it's got to be negative because it's a negative 3. So that's, you just did common denominator by reverse dividing, so to speak. You knew it had to be 4, so you just asked yourself, what number divided by 4 gives me this? Another good reason to line these up vertically so you can see that, oh, negative 3 is the same thing as negative 12 divided by 4. Same exact thing. And that's why they are equal signs. And then you can carry on. Now, when you're adding fractions, adding and subtracting, right? Fractions. You can put these notes if you need them. If you already know to do it, don't worry about it, but it just depends how much you remember. Right? You work on the top. And bottom is the same. So there's 4 over 4 here and 4 here, and the answer is also 4 on the bottom. It doesn't change on the bottom. Only on the top we actually do something when you're adding and subtracting. So if you wrote that note down, well, when you go to number 12, it's right there. So in this case, yes, this p equals negative 3 is the solution. So just right here next to it, I'm going to write solution. So if this was a problem that you're going to be doing later on, you can always check to see if it's right. If it's a quiz, you're going to do this before you turn it in. And you should know your grade before you turn in any quiz. You already know your grade. You checked everything. It's right or wrong. You spent as much time checking. If I wasn't speaking and talking and explaining everything, if you look at this, what do we have to do? We had to do, well, 3 is 12 divided by 4, and then I had to do a negative 7 minus 12 to get negative 19. I had to divide and subtract. And that was it. To check my answer to know for 100% sure if you're proving your case in a court of law that it's the answer positively. So why would you skip it if it's that simple? It's just one division problem, one subtraction problem. That's a little bit of writing, but A+ on everything is a pretty good reward. Move down. Do some multiplying. Check. Is 8 over 9 equal to 2 over 3 times 6 over 3? Now, we need a reminder for multiplying fractions. It's going to be top times top, and then bottom times bottom. And you can see how I'm abbreviating it. You don't have to write it down exactly like that. You don't have to write it down at all if you already know how to do it. I'm just writing it down one way. You write it down a way that makes sense to you, that when you look at it later tonight, you'll know what it means. If you just copy it down my way, maybe my way doesn't make sense. Do you have a better way? Use that. So we have 8 over 9. Top times top is 12. And here we have 9. We could cross cancel. We'll get the same thing. Are those the same? No. That means 6 over 3 is not a solution. That's not the right answer for this problem. Not a solution. The box one. And this is all order of operations still. That's really what you use order of operations for the most, is checking your answers. When we go to start solving these, it's the order of operations backwards. We're going to be doing all this stuff, but backwards. So if you're solving this, You might already know this. The first thing to do to solve this would be to add 9 to both sides. That's the last thing on the order of operations. This is add and subtract. You do it first when you solve. We'll get to that later. Let's go down and do a few of these. Let's see here. 17. So plug it in. Is 9 an answer here? Let's find out. Is 8 equal to 9 plus 3? 8. That's true. Lining up the equal signs. Anything that's not changing, you want to keep it vertically aligned as much as possible. Notice how the equal signs in the middle here because these are equations. You still want to keep them lined up on the front that are on the left-hand margin of the problem. 8 times 12? 6. So 96 is not equal to 88. So 9 is not a solution. You want to try the last one on your own and see how it goes? Check when you're done. You want to know before you leave if you got it. It's a good way of doing that. Now, when I plug in, just like I did in the front, I'm going to put it in parentheses. Remember that? So this B, there's no parentheses up here, but use parentheses when you're plugging it in and check. It'll save you some headaches down the road. This first. Positive times a negative. Yeah, negative 16. Four minus 16. Now I'm going to take up a lot of space here. So I'm going to try to keep these negative 4s lined up. And from all my years of teaching math, this is the kind of stuff, it's so small and minute, you would think, how is that even important how I write it down? So what if I keep it lined up? It's actually what makes the biggest difference. People that think they're not good at math, they start writing these things a little differently. And all of a sudden I'm like, hey, am I getting this? How come I'm getting this in your class? You must be a great teacher. Like, yeah, I'll take the credit for it, but really you're just writing in a different way. You're writing the same stuff. It's just more organized on your paper. So your brain just kind of follows it a little bit easier. You don't have to search and find, like, wait, where'd you get that from? How come? You know, if it's just lined up for you. Make your life easier. And negative 4 times negative 12 is positive 48. So then, yes, negative 4 is a solution. Now we have just a little bit of time left, and often what you do with this little bit of time when nobody's making sure you do something exactly can make a difference on how much you understand this. So a good suggestion I have for you, before you leave with any spare time, do the hardest problems that are left. That way, at least when you later on go to finish this, you already know, I've done the hardest ones, and if you happen to get stuck on the hardest ones right now, you have people you can ask and get help on before you even leave, and your life becomes a lot easier because you're not going home with some big old long equation and trying to figure it out by yourself. So start with the more difficult problems. This is actually the last one, but something that looks hard to you that I don't want to try this on my own without some help. Do that now. You don't have to go in order from,